Yes, you have stopped the.
Yeah.
Well, next presentation is by Jorge Antonio Gómez Díaz, and the title is Long-Term Changes in Forest Cover in Central Veracruz, Mexico, 1993-2014.
Thank you very much, Aaron. Then I will. You can see now my screen. Is this okay?
Yes.
Okay. Thank you. Thank you, Aaron. So, thank you very much for the invitation for this interesting symposium. I'm very happy to present some of the results of my dissertation, my PhD, and it is entitled long-term change about, but since I know that it is very relative, this is depending of the time when you started. So this is the data that we have available. So that's why it's not so long as we have seen before, but still it is important in tropical regions where we don't have a lot of information. So as we know, the most critical components of land cover change are deforestation and forest fragmentation, which are the most important drivers of loss of biodiversity. And also the loss of forest cover are the main threat to biodiversity, and it has a lot of evidence about the negative impact in several groups. And since we know this is completely caused by the humans, so it is important to document and understand the processes. Some consequences of deforestation are an increase in greenhouse gas emissions, and also the reduction of habitat connectivity, and with all the consequences, for example, for genetic flux in species. There is a lot of studies in Mexico where it's reported that in the last years there has been a forest cover gain in Mexico, even though there is a debate if Mexico is really undergoing a forest transition. So since the last century, the forest cover in Mexico has a reduction in the primary habitats, but also we have seen that there is an increase in the secondary habitats. But this is still in a debate, and there is a lot of, we need more information about to know if there is really a forest transition from forest loss until forest gain, because sometimes this gain is only because of some policies, as we will see in this presentation. However, this has led to a slowing down, and even if everything is going well, and eventually reversing of the ongoing land degradation and forest transformation in Mexico. In Mexico, there is one state which name is Veracruz. This state lies in the Gulf of Mexico. It's an interesting state because it has a high biodiversity with high degree of plant and animal endemism. And also it is the third state in Mexico with the highest richness of flora. It has all the climate types of the world. You can find from tropical forests until glaciers in the top of the mountains. So Veracruz is one of the states most important for conservation of biodiversity in Mexico. And especially in central Veracruz, there is a mountainous region that hosts important ecosystems that, even though are endangered, because of the threaten that is in this area. Therefore, all the species richness and floristic composition are affected by the ongoing deforestation and fragmentation of the native forests that still are in the area. Why is important to know all this? Because if we know what are the effects of the landscape on biodiversity, we can make some suggestions to the politicians in order to design some conservation strategies. So the objective of this work was to describe the forest cover change and fragmentation in central Veracruz from the 1993 to the 2014. We made two ways. One was with the forest cover change rates in the study area during 2 periods. And also we assessed the dynamics of the forest cover during this period. So with the methods, as I said, the state of Veracruz is here in the Gulf of Mexico, and our study area is in the central part of Veracruz, and it's an important area that covers approximately 7,000 square kilometers. And as I said, it is important also because in this area we find an altitudinal gradient in which in 80 kilometers you can find almost all the vegetation types of the world of Mexico, because we have a tropical forest in the coast, we have a temperate forest in the middle parts, and we have also pine forest or even some kind of tundra in the upper parts of the mountain. So therefore, it's considered a national priority for restoration to maintain ecosystem services. And there is a lot of information about flora, because in this area it was well studied from the botanical view. So we have a lot of information. So that was the reason that we were interested also in studying this area. Our primary source or primary data came from the satellites, especially from the Landsat 5, 7, and 8, from 3 periods, that is 1993, 2000, and 2014. And this, we have this limitation because Landsat was available before, but we have a lot of problems in the tropical areas, especially in mountainous areas in Mexico. So before of this year, the data of the satellite is not very reliable in a study area. So that's why we have this decision of doing this assessment with this data. So we use supervised classification of the corrected Landsat images using maximum likelihood estimation. We define training samples of distinguishable land cover and uses classes in each landscape. So we have a lot of data, a lot of information, a lot of empirical data of the study area. So we use it to train our model, and we have a good accuracy. Then our images were classified into 3 land cover classes. We have forest, secondary vegetation or degraded forest cover, and we also have the coastal and hydrovegetation that is very common in the Gulf. And also we have 3 land use classes, which is agriculture, no vegetation or any use, and other. And in that we use the urban, the bare soil, etc. For the assessment of forest cover change, we consider the remand forest as those forest areas that did not change since the 1993, And in this case, we conducted 2 levels of the deforestation analysis. The first one was change in forest, which was just know how the forest cover was changing in each period using mean annual deforestation rates, and also the change in remnant forest. That is the forest that has not changed since the beginning of the study. So that's why we call the gross forest loss in the area. And both analyses were applied to the total area and also on each forest cover. And finally, we also made use of fragmentation analysis in order to understand and quantify how these landscape metrics have changed through the period. And this is important because, as we know, fragmentation is also a component of the process of deforestation. And for that, we calculate the following parameters. So it was patch area, number of patches, patch density, and etc. We have several indicators, but this was the most important in order to understand how was the forest in different changes. Okay, what we found that this area has a lot of dynamic since the beginning of the study. When we started the study, we also have quantified how the forest cover has been changed through the different area. And interesting, what we found is that there is periods, for example, in 2000, when the forest has a reduction, and this was likely because of the expansion of the agriculture in the flat areas, and also the transformation of the middle areas because of the construction of roads among cities. For example, in 1993, and this is Jalapa, the capital of the state of Veracruz. And as you can see, there is a lot of forest cover surrounding the city. But after 2000, you can see more forest loss in the surrounding areas. And this was mainly because of the expansion of the city itself, but also because of the construction a lot of roads connecting the small towns in the area. The area covered by remnant vegetation was reduced by approximately 57%. That is more than half of the original forest has been transformed through the study period. And also for the whole study period, the mean net forest cover change rate was minus 0.17%. And this is what we had found, that is a pattern in Mexico also, that there is a high increase in deforestation rates, but also increasing in forest gains. So that's why it's almost near to zero. As I say, during the first period, the annual net forest change rate in Central Veracruz was higher. It was about minus 0.44%. And as you can see here in these graphs, we have divided by vegetation type also in order to know how was affected specifically each vegetation type. But as you can see, for example, in the first period, there is a lot of forest loss in both analysis, and this was higher, for example, in the gross forest, in the forest that is intact since the beginning. And this was reduced and even increased. There was a forest gain in the second period of the study. However, there are, for example, some vegetation types, the mangrove, for example, that has a continued decreasing in forest cover. And also in the gross forest, you can see a reduction of the forest loss. So we established that there was a regrowth of vegetation during the second period, and also the annual gross forest loss rate at the beginning of the first period was about 1%, and was reduced to 0.14 during the second period. About the percentage of forest cover, we have seen that 30% of the study area at the beginning of the study was represented by disturbed forest, then was increased in the 2004 in 4%, and what is dramatically changed is in the last period is that there is an increase almost to the double. So we have almost 60% of disturbed forest in the area. The remnant forest, it means the forest that hasn't suffered any change in the beginning of the study, was calculated at the beginning of the study of 2,500 square kilometers. And this, which was transformed into 271 square kilometers of secondary vegetation, almost 600 square kilometers of agriculture, and 135 square kilometers to no vegetation. And the most specifically forest type that has an increase in this change was in tropical oak forest, that is mainly in this area, at the mid of the elevation gradient. Also the humid mountain forest that is in this area, which is where the coffee, there is a lot of coffee plantation, etc. The tropical rainforest that is mainly near of the coast, and the mangrove that is obviously in the coast. What happened with the remnant forest? The entire core area of remnant forest increased from 3 square kilometers in 1993 to 18 kilometers in 2014. That means that, as we have seen, there was a regrowth of forest, and that makes more connectivity about the forest patches. Also, the mean proximity index was reduced. That means that we have a lot of patches that are dispersed in all the landscape. We have identified 1,000 of square kilometers of forest that has not changed since the beginning of the study, which we named forest constant. And this is mainly found in the mountainous area between the pine forest and the tropical forest, which is named the cloud forest. And this is important because this cloud forest has the highest amount of biodiversity in Mexico. It's interesting that this forest has been constant since the beginning of the study. And there is also a small corridor, so in the tropical oak forest in this area, and also in the ravines that connect the high mountains with the lower parts with the lowlands in this area. Okay, so what we can discuss or know about these results is what we have found is something related with the Mexican land use policies. And this is interesting because in Mexico, since the beginning of in the decade of the 70s, there were a lot of policies that were used to transform the natural vegetation, and that was because the government gave some rewards to the landowners to convert the forest to agriculture, because in that time the government says that it was better to have agriculture than forests, and even so the forests as oceans or not important areas. Also, the forestation was related to the implementation of agricultural and livestock programs. There is a lot of conflicts between the different government departments. For example, the Department of Agriculture gives some facilities that the landowners can transform the original forest and even give them a lot of equipment. And in the other hand, for example, the biodiversity department is trying to change this with a lot of programs to try to use the land more in an agroecological way. So there is a lot of conflicts in the policies in Mexico. Also, we have seen an urban expansion from the 60s and also a decline of forest cover and natural vegetation. On the other way, we also have seen a forest regeneration, and this was because of the abandonment of the agricultural activities by the population seeking employment. There is a lot of migration in the study area. People in the field are not interested in working in the agricultural area. So actually, Veracruz has a lot of migration to the United States, and this has an impact because the land that is abandoned is started to grow into secondary forest. And that's why there is a debate is really Mexico going to a forest transition, and it's not more that is only because of the social problems that are in this area. Also, as we know, Veracruz has a lot of extended use and vegetation loss originally because of this was the contact, the enter of the Spanish into Mexico. Since then, the state has been a reduction of the original forest. So it's also known that Veracruz has the highest rates of forest loss, and it is because of the history in the area. We found, as I say, a recovery of forest cover during the second period, and this was mainly the main driver was the abandonment of agricultural land due to high rates of immigration to the USA, and this is mainly because farmers have abandoned the agrarian lifestyle due to the implementation of the NAFTA. The NAFTA is the free treatment agreement in North America. So when due to this implementation, a lot of companies of the United States can come to Mexico and compete with the local owners, and most of the people cannot compete with the agriculture in United States because they have more subsidies, and therefore the agriculture is not more a lifestyle. The people that lives in these areas has a lot of poverty, and they are looking for better conditions, life conditions, and they decided to migrate. It is important also to notice that we have a forest growth. This is true. This is important that we have a lot of secondary forests in the area. This is good, but it is important to know what is the value of the remnant forest. That means the old growth forests are important because there is a lot of evidence that when you disturb or transform completely a forest, for example, this is the case of ferns, there is a reduction in the species richness. And it took a lot of time. For example, in epiphytes, it can take like 40 or 50 years to recover the original the original composition. And even though there is some evidence that the secondary forests are very, sometimes they give the opportunities that, for example, exotic species get introduced in the ecosystem with all the biological problems that we know. So it is important to know that the remnant forests that have not changed should be protected because they are very, very important for biodiversity conservation. So understanding all the patterns, dynamics of deforestation and fragmentation it is important and desirable in hotspots area of biodiversity, for example, Central Veracruz, because in this way we can understand the history, why we have now the configuration, and this can give some ideas for the politicians of how to manage all these forest transformation. Also, the region demands urgent attention in implementing preservation initiatives. For example, the network of protected areas is not enough in the study area. We only have like 4 or 5 protected areas that only cover 2%. And that is it. And as we can see, there are still remnants of forests that should be protected for the biodiversity conservation and the ecosystem services also. So thank you very much for your attention. I would like to thank the fieldwork assistants that helped me in this project. Also the Consejo Nacional de Ciencia y Tecnología for the scholarship for doing my PhD in Germany, and the Deutsche Akademische Austauschdienst, the DAAD, for also help me during my PhD. If you wanna know more about this work, it is already published, so you can find it here. And I don't know if you have questions. Thank you.
Many thanks, Jorge Antonio. Thank you for your lecture. You have here one question from Edgardo. He says, nice talk, Jorge. One question on the current situation after your study period. Do you perceive that reforestation programs like Sembrando Vida are being accepted by locals, implemented, and able to remain per long term?
Okay, thank you, Edgardo. Saludos. Yes, these programs of Sembrando Vida has a lot of controversy in Mexico now because was in the beginning the idea is good because they are trying to regrow more forests and also make more productive, for example, areas that have been abandoned by the implementation of some, for example, fruits or some matter for the use of the wood, etc. But the problem is that this program was made very generally for all Mexico, and since have been now seen here, for example, each area in Mexico is different, and also there is a lot of the context of the people that live in there is different. So I mean that the program should be more in contact with the people and more locally adapted, and not just going and follow a general pattern. Otherwise, we'll have the same impact that the previous programs in Mexico have gone. There are some evidence that people is trying to enter into the program because they give money to plant some fruit, for example, some fruital trees, and people are destroying and converting their forests to get into the program. So it is good in the beginning, but it is necessary to be more locally adapted to the reality of each area in Mexico.
Okay, many thanks for your response and for your nice presentation. I think there is no more questions, and I apologize, but we have a little time. We are delayed. So many thanks, Jorge.